Okay, this next section, you'll notice that all of these have an e here. Right, e is the base, the other ones do not. Now the other ones it was suggesting you use log, but I just always use natural log just so I know what to do always. Always just gonna use natural log. Let's see. We're gonna do the same thing. We wanna get this e to the 2x by itself. Once we get that by itself, we're gonna apply the natural log. So first thing we do is divide by 5. This gives us e to the 2x, right? The 5 cancels out. 50 divided by 5 is 10. Now that we have that by itself, what I do is do natural log, and what that allows us to do is bring the 2x down. So now we have 2x times natural log of e equals natural log of 10. Now, what is the natural log of e? What does that equal? Well, we have to remember what the base is, right? The base on a natural log is always e. Do you know what it is now? There's two ways of doing this. One way to ask this is e to what power is e? Or you could realize that we did a pattern where, like, when these match, the answer is 1. Either way, the answer is 1. Natural log of e is 1. You should remember this. That's the good thing about using natural log on these equations, is that natural log of e is just 1. To me, it almost looks like the word 1, O-N-E, but it's L-N-E. So whenever I see this, I almost read it just as 1. But yeah, that's what this is. Natural log of e is 1. So when I do that, it's 2x times 1, which is just 2x. Now I divide by 2. I'm not dividing the 10 by 2. The 10 is really inside the natural log. So the answer is just natural log of 10 all over 2. These do not reduce. They do not cancel out. Please don't do that. The 10 is inside there. It would be like dividing a number inside of a square root by 2. We can't do that. Okay, we can't get in there. It's kind of protected. Let's see here again. I want to get this e to the x plus 1 by itself. Let's subtract 2. Equals 14. Now that I have that thing by itself, I'm going to do natural log there, and what happens is this, as a group, comes down. X plus 1 times natural log of e, right? It just moves in front of the natural log of e. Over here we have natural log of 14. Natural log of e is 1, right? Eventually you won't have to write that, right? You'll just know that it's 1, and then 1 doesn't do anything there. So x plus 1 times 1 is just x plus 1. Subtract 1 to get x by itself, and here's what we get. X equals natural log of 14 minus 1. Again, this is not 13, okay? This right here is inside the natural log. Natural log of 14 minus 1. Again, if we wanted to do that to figure out what it is as a decimal, I guess we should here. Natural log of 14 minus 1 is 1.639. I want to test that. Let's check it in our equation. By the way, the e button is up here. Second e. Okay, it says x plus 1, so we found that x was 1.639 plus 1, and let's add 2 to that. We end up getting 15.99, which is very close to 16, which is what the equation said it should be. One more here. I'm seeing e to the power here, but I'm seeing the 8 and the 2. I need to get rid of those. So let's subtract 8. So that's 18 divided by 2. It's 9. Now that I have that by itself, I'm going to hit it with a natural log. And what happens is this, the 3x minus 1 as a whole, comes down in front. Natural log of e, that's 1. And so multiplying that by 1 doesn't change it. We should just solve this now. Let's add 1. It is very weird to see the 9 and the 1 like just sitting there, like kind of out, and we're not adding them. It's very weird. Divide by 3. So again, this, maybe you want to put a parentheses around it, just to say that it's inside this natural log. What do we get here? Natural log of 9 is a decimal, plus 1, and then I'll divide it by 3. This is 1.066. This has really important solving implications. We've seen this compound interest formula before. We've also seen the continuously compounded interest. Let's see. Instead of just plugging in and calculating with this formula, what we're going to do is we're going to solve for unknown values in this formula. If you go on to Math 1221, you will be doing more of this financial type of solving. Let's see, your parents, I want to write down all my variables here. A equals P equals R, N, or I think we saw it as K last time. We said that that's the number of times per year the interest is compounded. Your parents invest $10,000 when you're born, thank you parents, and want it to be worth $50,000 when you turn 18. If interest is compounded continuously, that's telling me that's this formula actually. At what rate should it be invested at? What rate? So we're looking for R. I like to put a question mark here. Approximate your answer to the nearest tenth. So this is what we're solving for. It does say we're compounding continuously, so we are using this PERT formula. Let's just go through here. It says they invest $10,000. Remember, we call this the principal. So I don't need N in this case. I need APERT. A is the amount that we want, and that would be 50,000. T is time, and we are going to be going for 18 years. We're letting this grow. And E is just the letter E, the number E. Let's plug these in. A is 50,000. P is 10,000. E to the R, which we don't know what R is, but we do know what T is. It's 18. Again, I want to get this thing alone, right? So let me divide by 10,000. Well, 50,000 divided by 10,000 is just 5. E to the, I'm going to switch these orders, 18R. Now that we have that alone, I'm going to do natural log on both sides, because that will allow this to come down front. I'm going to go up here and start a new column. So now we have natural log of 5 equals, the 18R is now in front, times natural log of E. Remember what natural log E is? It's just 1. So 18R times 1 is just 18R. How do I solve for R? Divide by 18. So I'm going to say R equals, let's see, what do we get? Natural log of 15 divided by 18. Oops, natural log of 5 divided by 18. .0.089. Now remember that this is an interest rate, so it is a decimal. We need to kind of move the decimal place over. So we need an 8.9% interest rate. So it's kind of cool that we can figure these things out. This is a really useful formula. I'll have to figure out a lot of financial things. Let's look at another one. It says Lee invests $5,000 in an account that earns 7% interest. If interest is compounded monthly, How long will it take for her money to double? So since it's compounded monthly, I know I'm going to be using the compound interest formula. A equals P 1 plus R over N, N times T. We need an R, we need an N, we need a T. Lee invests $5,000 in an account that earns 7% interest, okay? $5,000 is our starting amount, the principal. The rate is 7%, so I'm going to type it or use it as 0.07. It does say interest is compounded monthly. And so that means that if it's happening monthly, then it's going to happen 12 times per year. It says how long will it take? So that means it's a time that we don't know what it is. How long will it take for her money to double? Well, if she starts with $5,000 and she wants to double it, she wants to know when is it going to reach $10,000. Okay? So here's what we'll do. We'll just plug all these numbers in. 10,000 equals 5,000. 1 plus, okay, what's the rate? The rate is 0.07. N is 12. And then up here, N is 12 again. I always remember that these two numbers repeat. And then T, we don't know what it is. I want to know what this is as a decimal. 1 plus, because I don't want to keep that like that. 1 plus this. What is that? Let's see. I'm going to take it pretty far. 1.0058. I'm just going to do 2 3s. 3 3. Now what we need to do here is divide by 5,000. Because I want to get this thing to a power alone. When I divide 10,000 by 5,000, I get 2. Now, if I want to get to this exponent, it needs to drop down, but I can only do that by applying the log to it, natural log. So this is natural log of 2 equals, okay, what do we have over here? We have 12t is now in front, and then natural log of 1.005833. How do I get t by itself? I need to divide by 12 and natural log of 1.0833. Sorry, yeah, right color. I'm going to do that here also. 12 natural log of. That will cancel the 12 and this. The t will be alone. Now I just need to type that into a calculator. Let's see. Be very careful, put parentheses around that denominator. Let's see, natural log of 2 divided, parentheses, divided by everything in the bottom. What's in the bottom? Parentheses, 12, natural log, that's a log, natural log of 1.005833. I'm going to press enter, and I'm going to get 9.9 for t. It will take 9.9 years. It says t is 9.9. T is time, and it's always in years. The last example here would be, again, as I mentioned before, exponential growth and decay. And a general formula we can use is A naught, we said, A naught times e to the kt, where k is the decay or growth rate. Right? Let's see. Researchers recorded that a bacteria population grew from 100 to 300 in 3 hours. At this rate of growth, how many bacteria will there be from 24 hours from the start of the experiment? So I want to use this first. This is kind of giving me an initial information or data on it. And then we're going to use it to figure out this question, how many bacteria there will be in 24 hours. Let's see. These are popular type of problems in, future math classes. We're essentially building a model that's going to model the growth of this bacteria. So I know I'm going to use this, A equals A naught e to the kt. And I have a couple values here, A naught, I have a K, and a T. Remember, K is called the growth rate. And let's see, it says it grew from 100 to 300, and so 100 was our original amount. That's A naught, that's what that means. And 300 is our future amount, that's how much it was. After 3 hours, that's going to be a t. It is telling us to find the growth rate k, so I don't know what this is. It's going to be some number. Let me plug these in. This is going to be 300. This is going to be 100. E to the k, we don't know what it is, but we do know t is 3. I want to divide by 100 because I want to get this by itself and then apply a natural log. Let's divide by 100. E to the, I'm going to switch these around, just 3k, right? Now we will do natural log here, natural log here. What happens is this power now comes down. 3k times natural log of e. Do you remember what natural log e is? Natural log of e is 1. Divide by 3, we should get our k value. Remember, this is just natural log of 3 over 3. Let's turn that into a decimal. Natural log of 3, make sure to close, natural log of 3, close the parentheses, divide by 3. Looks like k is approximately 0.366. Does that mean, I think that would mean that this is like a 36.6% growth rate per hour. All right, now it says find the number of bacteria after 24 hours. Well, we've built the model. We said we started with this, and now we can say the original amount is 100. E to the k, we know what k is now. It was 0.366. And t. This is our model. As long as we plug in a time, we can calculate all of this and we'll get exactly how many bacteria there are at that time. So it's saying 24 hours. So we solved for k over here, and now we're going to use it in our model. That was the point of doing that. Let's see, 100 times e to the power 0.366 times 24. Okay, that's a lot. 652,894 approximately. $652,894. This is a lot. There will be approximately 652,894 bacteria in 24 hours. It's a lot of growth, but that's how bacteria grow. And it's 36% growth. I mean.